So in this video, we're going to do the same thing that we did in the last video, but now I'm dealing with squares that are perpendicular to the y-axis instead of the x-axis. So my squares are going to go like this. If you think about the post-its that we worked with, right, they're going to be going down in this direction. So the areas of each of those different squares that we get on our post-its are going to be different from when they were here, which is going to make the volume of this shape when I build it out different from the volume in the previous video. So I've written some of the things that we kind of figured out in the last video. And maybe I'll draw, so I'm going to have little squares like this, right? I'm going to draw one of them, right? So that's my post-its base. And then it's going to stick up like this. Maybe it goes up a little bit further. It's hard to draw on this thing. Oh gosh. All right, so anyway, it sticks up, but it's the area of each of those individual squares is the side length squared. So now I have to figure out what those side lengths are. But actually, before I do that, I think you need to figure out whether we're doing dy or dx. In the other one, I pointed out that, we had all these guys going like this and was adding up all these squares, right? Here they're going to be all going this way. So since they're all going that way, I'm going to do a dy because I'm adding up all these little slivers in the y direction. This sliver, this sliver, this sliver, this sliver, this sliver. The next sliver is a different y value, right? Different y value. So I'm going to do dy in this case. What that means is that just like when we've done our rotational volumes, I can't just subtract and leave things in terms of x's, so I'm going to subtract them and leave them and have things in terms of y's. So in this thing, I'm going to solve for x and get x equals, I'll call it, I'll leave it like that, x equals y over 2. And in this one, I'm not going to show the work. You would multiply by 8 and cube root. 8 is cube rootable, it gives me 2. So for this one, I would get the equivalent version of this relation is that x equals 2 cubed root y, like that. So from here, I want to do this length right here. So what I need to do, I said in the other one, I did top minus bottom, right? For the x's, for the dx one. But in this case, I can't really do top minus bottom because I'm going side to side, right? Like I'm going side to side. And this is the same height as that, right? So what I need to do is do right minus left, or outer minus inner. So I'll write right. So this is my side length. This is not my area. So my side length is right minus left. So the right side, and I need to do it in terms of y, is this thing right here. So what I get is 2 cubed root of y minus, and over here the left side is y over 2. And I do that, I write them in terms of y, because I'm doing all of this, I'm going to integrate with respect to y. So that's my side length. My area is side length squared. So I can go ahead and set up a volume equation. Volume, and it's the same thing as the other one. It's integral of side length squared dy in this case. The previous one, it was just dx. So that's equal to integral, and I'll fill in the bounds in a moment. So this is, my side length was this thing. So what I'm going to do is go in parentheses, 2 cubed root y minus y over 2 dy. And now the question is, what are the bounds for my integral? What do I go from and to? So notice here I'm going to start at this low point, and then I'm going to take this slice, 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 all the way up until I get to here, right? When I get to here, the y value is 8. So I'm going from a y value of 0, and I do it with y's because I've got dy. I go with a y value of 0 up to a y value of 8. So So I write 0 and 8. And from here, once again, just like I did in the other one, I could integrate this if I wanted to, but I'm just going to use my calculator for it. So I did fn int on this on my calculator, and I got 9.752. So you can see, I think in the previous one, the volume was like 19 point something. So they're significantly different. And that's that. You will have one problem that, one or two problems that require you to do this with triangles. So while I've given you the formula for the volume for a square one, I'd like you to think about how an equilateral, or sorry, how a 45-45-90 triangle like that is related to a square, and how you could use what you know about this thing's volume to figure out, or sorry, what you know about the volume of something constructed from squares relates to the volume of something that's constructed from triangles. They should be very closely related.